Okay, right. So, hi everyone. We're gonna start the discussion of the second chapter in our do for the Devops for data science book club. So I don't know if this chapter had like major updates between like it's just one edition of the book, right? Because I found that the slides were like very different from the actual content of the chapter, so I remove everything. But okay, so our learning objective for today, we're gonna learn about the three-layer application. It's an architecture to build apps. Then we're gonna focus on the presentation layer, and we're gonna learn why is it important and how we can handle the data that goes to the application layer. And then we're gonna learn a little bit about APIs. Okay, so the chapter starts saying that we like as data science we mostly code pretty poorly architected software, and that is fine most of the times. But when you're trying to actually share your project, or when you're trying to make it go to production, that's when the problems start. So the chapter discusses a standard software architecture that is used for apps, for software apps, like general software apps, and it's called the three-layer architecture because it has like three layers or tiers. And these are the three layers. We have the data layer, and that will be mostly a database or a place where we store our data. Then we have the logic tier, and it's also called the processing layers sometimes. And we have the presentation layer, and that's where the user interacts with our application. The chapter also mentioned that sometimes in software applications, like it is called the backend and the front end, and the backend will be both the logic and the data tier, and the front end will be the presentation layer. And then the chapter discusses that okay, like this is an architecture for apps, but we don't actually build apps. We have data science project. So how can we use this layer, like this architecture, to our projects? And that was something that I've never thought about it. So like a year ago we did the advanced art book club, and then with Oliver and Steffi is from the art open side community. So I kind of like I joined the community, and I joined their champion programs. Well, it's a mentorship program where they help you build your own packages. And my mentor, that was the first thing she said. Like she said, you have to think about like these three layers. And it made so much sense because I honestly I've never thought about them. Like I don't know if you actually think about them when you're like designing your data science project, but it's something that I've never thought about it before.
Maybe it's good to ask other people first. Like I would like to say congrats, Diana, to be like a part of this pool of open science. Yes, sure. Like maybe others want to share something about the three layers. Good moment to ask.
Just to say, I was nodding my head vigorously along with what Diana was saying. Same for me. I feel like in the past I'd never thought about this formally, but somehow I was reading this and it's like this makes so much sense. In my best moments, I guess, I feel like I'd sort of like intuited these kinds of concepts, but it's really nice to think about them formally. Yeah, so I was really happy to read this chapter.
I think for me, before reading the chapter, I had an experience of creating a Shiny app, which initially I thought would be just a small app and I didn't have to create these layers. But as the project went on, I found that I have to separate the business logic in a different package and probably create an API. I'm still working on that project, and now this chapter makes much more sense to me.
That's great. That's great.
Yeah, I like also like this. There is like, and people have like tremendous opinion on what should be in the each layers. So before going into like it's people tend to be very opinionated into like what should be and not should be in. Like when I have my own opinion, but you know it's changing around project and learning. What I think is also very important is like you compartment your working workflow, and so you can specify, let's say like if you work in team, usually like you're gonna have like the front end people that's gonna ask you like what's my input, and basically what's their input is what you are putting on output when you work in the backend, which is mostly my case, and you have to define that. But when you work alone, it's also good to start defining what's like. I think it's good at scaffolding it. Also, like you're gonna, and this is also what the chapter is. It's about architectures and how do you decide which part is which part, and starting like by writing your thoughts and things. Oh, look, let's say like it's a Shiny app. The rendering button. I mean the some button will consume that data to change something like some map or some graphics. And this is good, I think, to start by a piece of papers, and these layers help also, even if you work alone, I feel.
Yes. Yes. No. Yeah. Yeah. It makes sense. Yes. If you work alone, if you work with a team. Yeah. So yeah, that's great. It looks like it was a very helpful chapter for all of us. I'm glad. Okay. So yeah, as I was saying, like this architecture is usually used to build software apps, but we have data science projects. So what are some aspects that we have to think about? So yes, like as Umair said, in data science we can think of an app usually as a Shiny app, and the chapter also mentions some Python framework that I've never heard before, and I guess those are also used to build data science app. And also, like we have projects that might have many components. It might just not be a single thing. Also, the data flow, it's yeah, the flow of the data is different in apps and in data science projects. So when we interact with an app, we click buttons, we select things, we input data, and the app it's responding to the user input. But for the data science project, that usually is not the case. A data science project will be updated when the data is updated. So that's kind of another thing to think about. And we usually don't have ownership on the data, and we're not the people who will decide where the data is stored. So that's a big thing to also think about, because like I'm sure it will be easier to work with databases like SQL databases, but like who has their data in a like beautifully formatted database that we can just access using an API. Like that's almost never the case. So yeah, that's also another thing that we have to think about. Mm, so the chapter is actually like focused a lot in the presentation layer, because I think the next chapter will be about databases and data APIs. So it's gonna be like bigger on the application and the data layer. Yes, Oliver.
Yes, I usually have ownership on the database, but even if you have ownership of the database, let's say like you are ingesting data from API or CSV, you don't have ownership of the structures of the raw data.
Yes.
And the structures can evolve, which is become tricky. But I think the question of ownership of the data is usually you are not the one that's produced the data. You are consuming it from someone, let's say like government sources or like sales or like inventory, like it's that. But yeah, it's even if you do not have ownership of the SQL, like you mentioned DuckDB later, so maybe we can discuss that. And know that I think the first book club, they used the beta version of this book. So they have run the book club before the book was printed. So that's also explain a lot of change.
Okay, that makes sense.
And go for it.
Mm,
Sorry, yeah.
Okay. So yeah, we have the presentation layer, and that's what and that's the thing that our user will consume. So we have to choose it carefully. So the book mentions different options for our presentation layer. We can have a job, and that will be a workflow that will change something in another system. We can have an app. We can think about a Shiny app. We can also have a report, like a quarter report, and it might be static or it might be a little bit like it can have some interactive elements, and it can also be an API to allow other machines or other developers to consume what we built. And the chapter has this very nice decision workflow for our presentation layer. Do we want something for human consumption? Yes. So is it gonna be static? Yes. Then we can just build a simple report. Uh, does it have to have like a live data processing module? If it has to have it, then we will mostly build an app, and if not, we might have an interactive report. And if it's not for human consumption, if it is for machine consumption, some consumption, then we can think if it's gonna run in batch. If it is gonna go as a batch job, then we have a job, and if not, then we may have an API. So I don't know about you, but I mostly just like I mostly have static reports almost all the time. Now I'm actually building a package, but like yeah, reports will be my output.
That's a good question, everyone. I guess like go ahead.
I was saying for me, it's generally a Shiny app. So at my lab, they mainly do, they build mathematical models. And when like the output tends to be an app where the user can enter different scenarios and then explore stuff. Yeah.
Nice. Someone else wants to share? I guess jobs and APIs are less common, right?
API less common, yes.
I guess it
Mostly,
depends on where you're working, though. Yeah.
yeah,
For me, it's static reports and Shiny apps. Yeah.
but API are less common. I mean, I feel especially with R, because usually they will be deployed right now. I think like the main framework to deploy them in Python is Fast API, and Plumbers is gonna go to Plumber 1 to Plumber 2. And yes, I will say API is less frequent because of that. Uh, I I wanted to add few stuff that I think lack here, not from your presentation, but for the book. The question is like, who's the users of the data, who's the consumers, and depending of their profile, this could also change the branching. So let's say like, for example, like if your consumer are data scientist, which was my case when I was working, and so their consumption is through codes a lot of time. So a package can also be like a presentation layers. I think you mentioned that quickly for the business logic, and but I think it sometimes also like the business logic is as important that you want to document it in the package, and the package become also like the presentation layers. And that's because like the users that I had were people who were comfortable writing code and want to interact with the data programmatically. But if also like you have people who do not want that, usually like this is where like you will build some app, some dashboard, some stuff like that, so they interact with some web component with the data. I think this is one point that also like should be mentioned, like when you build that, thinking who's gonna be the users and how they gonna interact with your presentation layers.
Yeah. Yeah, because you can have like it's not a one single presentation layer, but you can have multiple presentation layers.
It's true. And then how do you divide your project?
Yeah.
How do you architect that if you have multiple one? I have no good answer of that question, but that's typical. Yeah.
Mm.
I have
Um,
an example that I think could be considered as a job. It's a GitHub action for updating data on a database that the Shiny app then shows. And it updates midnight every day. And that's because if you do the same process in the Shiny app, it would take forever because there are so many people and I aggregate data to find averages for certain variables. So I do that every night, and then that updates the Shiny app.
yeah, that's a great example of jobs. I complained a bit of social media that this chapter did not include Target. Target is an R package that manage workflow, which is basically like another way of managing. Basically, a job will be like an R script that's run by cron or GitHub Action, some compute somewhere, and some scheduling somewhere. And Target is a good way of having like the R script divided into more component pieces. But yeah, if you do not know Target, you should look at it. It's very good. I'm a salesperson for Target. Yeah, maybe we'll see example for job later. So I'll let you go back. Yeah.
Yeah. Okay. So what do we want from our presentation layer? As Oliver said, like I'm sure a lot of people have many opinions about what should go into the presentation layer, and what the book the recommendation that the book has is that we should put the the least amount of work and data in the presentation layer. So it's a like I don't know if we're thinking about a Shiny app, if it has to hit a button and output a figure, like it should only consume the data that it needs, and it should only call the function that it needs to actually output the figure and nothing else. So yeah, these are the recommendations that the book have. Do less in the presentation layer. Keep only the code that shows something to the user or that collects input from the user and nothing else. And also have small data because you want high performance, especially if it is a Shiny app that is gonna go to the web. You don't want your user like waiting until you make all of the calculations. So it also gives us like some points to think about. Like, can we do some pre-calculation before the data goes to the presentation layer? And also, can we use the granularity of the data? Like, it wouldn't make sense to have data. The chapter talks about data in a sales in a store. It wouldn't have it wouldn't make sense to have data like everyday data if the users are just gonna look at data, sales data for an entire week. So we should be careful about the granularity and figure out the dimensions that will actually make sense to the user, so that we don't have like tons of data in the application layer. Yeah, I don't know if you want to comment on this.
Yeah, I have some comment on that. Or just like I have comments and reminders. Uh, this is like, I don't know if after that I didn't look at the slide, but like this is first there's the eager lazy dichotomy. Either you load all the data before like when you open the pages, or either like you load it as you process it. Oh, you have okay, so and the question of granularity and dimension are huge is a framework that's called like data warehouse according to so data warehouse is a term that's mean plenty of stuff, but there's like this guy is called named Kimball. He wrote plenty of book about it. Data warehouse Kimball, like this is the classic. I'm gonna data warehousing or data warehouse. I don't know. Like, its name is Kimball. It's old now. It's 60 years old. And it's basically like how you manage granularity and the dimension inside of a database. But the book does not mention it. I don't know why, but it's a good and it divides basically like your database into what you call fact stuff that are gonna updated. Let's say sales, it's a good example. Sales are updated every time you do a sales, and dimension. Let's say your clients are like your product. Your products are updated not less frequently. They're updated as more you get product, but one product is always one product. So you call that dimension. So I think like and there's a whole reflection on the granularity stuff. That is not going too much into it, but like if you're interested, you should look Kimball. The
Okay.
other name that's talk about that is Iman, but I have not read it, so I don't know.
Yeah, thank you for the resource, Olivier.
Kimball and Iman, that's it, yeah. But they are very close definition.
Okay.
Yeah.
And yeah, I guess like putting a lot of focus on the user, it's something that yeah, sometimes we don't do as people who build data science project, but it actually makes sense. And yeah, it's completely new for me too. So yeah, that was really good. And the chapter also give us some ways that we can make the data small for the presentation layer. So it tells us that we can push some work into the data source, so we do anything we can do before you actually put the data. I'm sorry, I have some typos because I can make the auto suggestion like the spell checker work in Positron or in Visual Studio Code. I don't know why, but it doesn't work. So yeah, I knew this was gonna happen. So yeah, we have to like try to do anything we can do before we actually pull the data out of our data source, so that we don't pull everything and then do the calculations or the processing. As Olivier said, we have to like try to be lazy with the data pulls. Only pull the data when we actually need it. Like don't pull everything in the beginning and then work with it. No, only the thing that you're gonna need when you're gonna need it. It also mentioned like sampling the data, but I guess that will only make sense for machine learning tasks. It wouldn't make sense for a lot of other tasks and a lot of other projects. And also this thing called chunk and pull. It is like identifying groups that will make sense. Again, if we go to the sales example, like if we have different stores, only pull the data from the store that you're gonna that you're gonna need. Mm, so yeah, I just thought that the sampling like that wouldn't make sense in many applications and in many tasks.
I have not found a good idea where sample works in outside of like testing stuff. Testing stuff is great, but like in a app, maybe in a report, like I don't know. I have not find a good idea why it works. But check and pull, sometimes it's gonna be called a view. Like when you generate, like you have in the database, like you have some logic in some, so database can be organized by layers also. And you will have like layers, which is like your layers in production. Sometimes it's called gold. Sometimes it's called, I don't remember, like every framework have their name for that, but like the layer that's consumed by the app is sometimes it's usually produced by layers at the lower level, which usually is a schema. So you have a schema where your data is kind of clean and ready. And generally what you do is like you set up views in other schemas that are generated by the layers automatically. So, and the view usually will do like the check and pull or aggregate as another granularity.
Okay.
So maybe like check and pull, sometimes like people are going to call them view, which is a view. It's a dynamically created table.
Okay.
Maybe.
I have a naive question that I've never used a database, regrettably. Hopefully I can change that in future. Our IT department keeps our hands well away from anything that's not on our devices. Anyways, like I really find this idea of kind of having the data source, let's say the database, like do these kinds of computations. How do you kind of at like a high level, how do you orchestrate that? Is it basically a cron job that you kind of like populate tables in a database on a certain thing, or do like databases have their own logic about having runs that execute a certain logic? Just curious if you could maybe like say a few words about that for people who have experience. Thanks.
So yeah, no, that's a great question, and like since I started working with R, I haven't touched a database like in so long. And but yeah, databases like you can build queries, and something that I really like about dplyr is that the verbs make completely sense to as an SQL query. So you will build a query, and you can make it as complex as you want to do exactly that, to only pull what you need. And like yeah, they also have jobs, and they have indexes to help you do the things faster. And you can build views in the like directly in a database if you identify the groups to do this chunk and pull. And yeah, like they are very very useful, and yeah, they can do a lot of things for you.
Yeah, I'm gonna go back to another level. Let's say like you are a company that sells stuff. So basically you will have like a database that's manage operation, like basically like manage your inventory. You are, let's say, selling brush tools or whatever. You need to know how many brush tools you have in specific warehouse, etc., etc. At the same time, usually you have an analyst team or whatever you call them that's gonna produce report or inform your leadership about what's are the issue. So usually like you have people who moved the operational data. That's the one that's managed like your inventory or like and do some stuff like let's say like send message, oh, we are lacking toothbrush in said department, we need to build more, etc., etc. So this is one part of the company usually. And then usually you build on this top of this operation layers to a data warehouse where analysts can consume it without messing the data that are in operation. So the database in operation are handled by hub. That's like they're like designed to have like high transaction. So adding stuff, removing stuff, counting stuff, and then you move all of that. Like it can be like people have a lot of disagreement, which should be instantaneous, should be like in batch, should be like, and then you move back to another structures that analysts can target, and app for data scientists can be targeted. And usually like the workflow is different because like an analyst will pull a lot of data, but not frequently. So that's and so basically like to try to continue to answer your question. Usually like your IT department should provide you with an environment where you can like safely play. Like you can safely pull data, not write anything into it, but you can safely pull data without crashing the operation layers, which your company dependent, but so that they will move data from you in some places, organize it where you can safely target that data for whatever your needs are. And databases are great. I think our users should learn more of them, even in your daily workflow. I don't know if that answers your question.
No, that really helps a lot. That gives a lot of kind of context and on the problem. No, that definitely helps. Thank you. I've got some learning to do.
Basically, like also like one of the advantages, like if you have like a server with database, the compute will be done in the database, not in your computers.
Yes.
But then you will load it into your session, depending on you interact with it.
Yeah,
Yes.
my problem is I work with small to medium data, so it's kind of I don't face the problem yet.
Yeah.
Anyway,
Well, I'm opinionated on that. I will give my opinion. Even if you work with small, medium data, it's good to have a centralized place. And sometimes a database fit that needs.
Yes. And like also I was just like looking at images for databases schemas. Because yeah, even though it might be like small or medium data, having it organized like in different tables, it makes a lot of sense. And yeah, it will put the database to work so that you can just pull the data that you actually need. And like all of the joins, all of the joins, all of the merges that we usually do with our data in the player, they will happen in the database.
thanks.
Okay. So yeah, then the chapter talks about like where to store the data, and it says that it depends on how often it is updated. If we put it like right next to the presentation layer, so in the presentation bundle, then those two things will be updated together. And so it said that we can put the data in a file system, like it will be just like in our computer, but that will make it hard for deployment. We can also use blob storage or like a cloud storage as such as S3 or Google Storage or all of these products, and they usually have packages. It mentions Boto for S3, or it says that we can also use Google Sheets like has an intermediate step, but I don't think that's I don't even yeah I don't think that's a good idea, because like the amount of effort you will put to make like the connection to the Google Sheet and everything, like you could do something else with it, like you could use a cloud storage instead of going to Google Sheets. Yeah, I don't know.
I personally hate the Google Sheets workflow. I hate it with all the possible pain I have. Why? Okay, it's fine, but like, like then you need to write a ton of boiler codes to check what the entry is. You not only like you need to write the connection, which is very similar to a database. I exaggerate. It's not. It's an API, but it's still. I mean, you can say functionally the same, but you're still unsure of what you're gonna get. And people like if it's just adding and modifying data, I think it's fine. But then people start changing the label or use the label inside of the Google Sheet to, let's say, render a title of a graph or render like some stuff like that, or like legends, or like add documentation. And at that point, this is the point where like if it's just updating data or tweaking some data, I think it's fine. But more you go into like using it as some kind of layer to handle metadata, it starts to be dangerous, in my opinion. I don't know what you think, also think about that, but yeah. But I have seen that tremendous. I mean, it exists in probably every company.
I didn't know that it was a thing. That people actually use Google Sheets for this.
And I'm
Okay.
pretty sure people use like SharePoint, OnePoint, whatever, like the cloud service provider for file spreadsheets. They're gonna use it and target it to do stuff and ask you to do that. Airtable. I have seen it with Airtable. I have seen it with like, and it's break all the time. All the time it's gonna break. So it's work as a proof of concept, but if you want to do more, like I think it needs strong convention, and people will break this convention. But like, feel free to use. After I've said that, no one is gonna say anything. But yeah, um,
Yeah, I've never used it, but yeah,
but you can also, like, where to store the data. If you have an access to a database, use the database. No,
yeah, yeah.
they are specifically designed for that.
Okay. And it also says that we should think about where, or like how and where do we store our intermediate artifacts. We can use like if we're only using like raw text, we can use CSVs, or we can use pickle or RDS objects, or use DocDB. I've never used DocDB. I don't know if someone has experience.
Yeah, I've given a talk recently at user on DB, so and using especially like for this kind of workflow. So yes, DuckDB is amazing.
Okay.
DuckDB is kind of the SQLite. So SQLite is in. I mean, it can be in memory, or it can write also like a file on where you want. It can also target Parquet, CSV, whatever you want. Also, I mean, the source of it, but it's basically. It's in-memory database, so instead of working, and it's in process. So you start it will be inside of your process. It can generate more sub-process, so it can be tricky. You can use parallelization behind the scenes. So yes, it's an amazing product that started as an R package. I mean, and then behind the scene for an R package. No, like it's very, very, very used package for data processing, and even like a storage sometimes.
Okay.
If you have like I don't know, it's really depend of your kind. I don't know which kind of data you work, but if you have tabular data, it's very good.
Mm. Yeah, I usually work with tabular data, and I will save the intermediate objects in either CSV or Pickle or RDS. Like I will use anything.
But yes, yeah, DuckDB or even SQLite. SQLite is great. Like, what's great with DuckDB or SQLite is like you can have SQLite command line tool at DuckDB and SQLite both have very nice command line interface. So you can you can use R to connect to SQLite or DuckDB, but you can also directly go in at the layers of the database, and they have like very nice function. I mean, very nice interaction. So if you want to debug stuff, at the level of DuckDBs or at the level of the your data object, it's possible. Also, DuckDB codes, the SQL codes that you write, is very close to PostgreSQL, so it makes your code very easy to move from one database to another. Use DuckDB.
Nice. Yes, I'm gonna try it. Yes. I'll definitely try it. Okay. And yeah, the book also says that we sometimes need to create APIs, and although I guess they will make sense they will make more sense for the logic tiers, for the processing tiers, and not actually for the application. And we will consume the API in the application layer. So yeah. Mm, so API stands for Application Programming Interface. As I said, it is suited for the middle tier because it allows you to separate the processing logic into functions. And yeah, it said that we should think about APIs as function as a service. They are functions, but they run in a completely different process. They're not like right there next to our application layer. And it's yeah, like this is the diagram for how APIs work. A client will do a request to an API. The API will talk to the server to do the processing. It will get a response, and then the API will output the response to the client. And yeah, I've never used APIs in R, but yeah, as Oliver mentioned, you can use Plumber or Fast APIs.
Fast API is Python, Plumber is R, and now you have Plumber 2.
Okay. And is it very different from Plumber 1?
I think Plumber 2 introduce something similar that's Python decorators, which basically an API is going to take some argument in somewhere, which usually is k-value stuff. And it was hard to implement that into R. I don't remember what, but now the Plumber 2 implement that using R Oxygen documentation. So for people who are not aware, like you can in R Oxygen is like some kind of meta language that transform like some comments into code into stuff, and they are like expanding that right now. So it's kind of cool, but it's magic that happen with a lot of parsing.
Okay. Okay. And I added a small slide about REST APIs. So REST stands for Representational State Transfer. And in REST APIs, we have resources and we have URLs, and we identify each function with the URL, and those URLs tells you what can you do with a resource. And like APIs use HTTP method to do the create update, delete, and what's the R? Create
Read?
read, yes. Yeah, thank you. Create, read, update, and delete operations, and they're like they're called rest because they are stateless. They have no, they don't know anything about the client, so it's just what you sent in the URL, and that's it. And the responses and the requests use JSON or XML to actually like talk to the server. And I just added the URL for the data access API for the Dataverse. And yeah, like this will be an example of one of the URLs to use. Um, so this will be the resource, the data file, and in this case you're only access it, you're using the get HTTP method to read a resource that will be identified with this ID. So this will be a function that will just like it will bring the data file with this ID. And maybe we have another one. There was, but yeah,
Usually you provide your key somewhere. Like you need to provide an authentication that we
yes,
get letters in the book.
yeah. Yes, in this case, like for the database, you have an API token to get it authenticated to the server. But yeah, like these are the things you can use, and that's how an URL in a URL in an API will look like. Yeah, I don't love the documentation here, but I mean it's fine. Yeah, I don't know if you have some comments or questions about APIs. I think like it's more common that we will consume an API than actually like write or create an API. But yes, as Umair said, like
The case where you produce API, which is not my case a lot. I mean, I produce some, but like what I have seen also, it's people doing MLOps. Usually, like the model, it's gonna be represented as an API, and the model usually you want to predict something. This is the output, but then it takes some parameters to generate the output, let's say. And this is what we're gonna see, I think, in the book, is like you have this linear model about differentiating the penguins, and it's like some parameters, and it's gonna tell you, like, for example, what the penguin is.
Okay. Yeah, and finally, the book suggests that we should write a data flow chart, so we actually like know how our data is going from the data layer to the processing layer to the presentation layer. And I think that's also a very, very, very good idea, and that's also something that my mentor in the R open side suggested. So we did like the package and the functions that I'm gonna have are very, very simple. So mostly it will be just like get something. But so my data flow charts look very, very simple. But yeah, it was a great exercise because I haven't thought about that, and like actually writing, like actually building this data flow chart was a great exercise, and it makes you think about the names of the functions. It makes you think about yeah, like what, like how much of your data are you carrying throughout the layers. And like right here, I don't have a presentation layer still, but we're gonna add that. So yeah, I strongly suggest this step for all of your projects. And yes, exactly. Naming things is one of the hardest things. And yeah, that's it. So as I took some of the comprehension questions from the book, but and I added some questions that I wanted to ask you. Like, do you actually think about your application layer? Like for me, I guess like this is gonna be the first time, and now I would like to pay more attention to that, even though it's just like for me, I don't think it's gonna change. Still, I will have many reports and figures, but I'm gonna try to separate the work that I put into the application layer and move a lot of things to the logic or the processing layer. Mm, yeah, so yeah, we can also talk about like what libraries or packages we use to implement this three-layer architecture in our or Python. I guess like Shiny will be one of the main ones.
I
Yeah,
actually
how
have an adjacent question, if you don't mind. I saw that you're using Miro. I was wondering for the just sketching the data flow models or other things like what people use. I've been using Excalidraw, which I find is kind of nice for drawing things, but then I feel like there's almost like a notes layer that I don't know how to capture, or whether there are tools that allow you to do that. So you could kind of like double click, so maybe even literally double click on a node and then better understand what's going on. I'm just curious what people okay, Mermaid, yeah. Yeah.
yeah, I use Miro because that's the one my mentor suggested, and I like it. It was really easy. But Mermaid, I'm gonna take a look at my Mermaid too. Yes,
Yeah, I'm so bad at it. I'm gonna like I need to spend like a weekend with Mermaid, so I'm gonna be good at it. But Mermaid is a very powerful tool. But yes, I'm bad at it. I think Pen and Papers is great also. Like, oh, I don't know. I think he used another app, like, like he do schema with something. I don't remember. I know I learned about it, but you can go into here. You go into tutorial.
tutorials.
Open editors, maybe? No, open editors.
Okay.
Yeah. No, you don't need to use like a paid stuff. And that's it. That's how it works. And you can edit it from the here. It has a specific syntax, and then you have like a pre-sample diagrams you can use on the bottom. No, on the bottom of the other side. Yeah, here, like let's take you want like I don't know, click on something. It's good for like a lot of use cases. I mostly use flowcharts and this stuff like the one you click on it with the I mostly use I use also like this kind of diagram too, like the multiple to
Yeah, it's really nice because
and
like just write it
you
Word.
yeah, you can write it as code and you can integrate with Quarto. Also, Quarto like can run the Merman engine. If you go like if you open Quarto and shoot Mermaid, they have Mermaid engine.
Okay.
It's very good to use like this tool to prepare your Mermaid Mermaid, and then you can just copy paste it in the chuck into Quarto.
Okay. Oh,
But
that's great.
Excalibur is great too. Like I use it too also. But like right now I think I prefer Mermaid. Even if it does not have everything that I want. It also like use CSS, and it kind of can respect the CSS of your top project. So it has theme and stuff like that. So yes.
Okay. Nice. Nice. It looks really nice. Mm, yeah, how do you reduce the data requirements for your project? I don't think I don't think you can do that sometimes. Like they're just there. And yeah, like you can reduce the data you bring to the application layer, but reduce the entire data requirements is I don't know.
Well, you have some tricks that you can use first. But like you should definitely try to reduce it. More data mean more code. More code mean more bugs. More data mean also more bugs. So as much as you can, like this is something like data is equal waste. So more data you have, more waste you can have. More it's gonna take place. Let's say like one way of reducing data is defining types. If you have a database and if you define types, you're gonna like take less space. You can also reduce it by using binary formats that you mentioned. But it's also like having discussion. I mean, I know the POSIT people are kind of bringing the idea of data contract, which is basically like a negotiation with what you provide and what it's going to be used. And if you do, this is basically like a meeting place, but it can be document, obviously, where you just said like, look, we need that, and that, and then you just provide that, and that, A, B, C, and you don't provide D. And if you need to provide D, you need to have a discussion on why you need to provide D. But I think it's hard, and especially because like data, usually like you start by exploration, and you don't necessarily need, and what you mentioned, you don't necessarily know what you're gonna need. But at one time you need to remove columns and or specify their type. I was this guy in my previous job, but you need a guy that do that or someone. Someone that said like, look, reduce that, remove that. Like administration system folks do that. That turn off something, and if no one's calling them, that means no one needs it. But this is a bad way of doing it. This is a joke in the sysadmin world. Like you turn off something, and if no one's calling you, that was not needed. So that's one way of requiring data requirement. You remove the data until someone said, "Where's the data?" And then you can say, like, "Look, maybe we should have a discussion of what we need, and then we can write it somewhere so I know you need it, and then I can maintain it. And if I need to maintain it, that also means that I need more budget to maintain it."
Yes.
Like bringing the notion like this as a cost, is there on your times, or like it's the way I will solve it? I don't know what other people do, but I mean, having data as a cost, yes, it's a cost.
Yes.
So paying that.
Yeah, everything you said make completely sense. Yeah.
Other and how do you handle intermediate artifacts? Yeah. I guess it's depend of what the artifact is and where. Like it's for me, it should not. I mean, if you are in production, this should. I mean, this shouldn't be an intermediate artifact. This should be already prepared. And if you need, and in development, I use target. With target, will handle my artifact for me
Okay.
because like I don't want to think about that. This is like, oh, I need to and DuckDB is great also for that. So because like you're gonna have a shell script, I mean a shell script that have a SQL inside of it that's gonna generate all of it. But and target is very, I mean it's not similar, but like the idea is the same. Like you don't want to produce what's an intermediate artifact is you are running a workflow and then you go to lunch and you're gonna kill your session or something. You remember our session are cattle, everything should be killed and restart from new. But then sometimes you generate something that take times. So you don't want to come back and then spend another hour generating it. So that's you're gonna save the intermediate artifact as a CSV or RDS or Feathers or R or whatever you want. I think this should be automated by a framework. That's my opinion. And usually the framework, the popular framework now, if you are it's only target. If you use SQL, it's going to be DBT of SQL match, or people use Airflow also. But like it's need to be generated by something you don't think. That's my opinion, because you're gonna write a ton of boiler code to do that. That's need to be maintained. I don't know.
Is there anything on
Okay.
the Python side that does the same thing as targets? I mean, I know targets is like loosely inspired by make, but I don't know if make like does like this intelligence about whether you need to regenerate an artifact, and if not, you skip to the next step.
Nick, but I never use it.
Sorry, say that again. Which one?
Nick.
Make.
That's not. I'm not the one who invented it. Module.
I guess one issue that I haven't like that I and like one of the reasons why I don't think about this too much is that I work with like static data. Like the data we produce, like the sequencing data is there. It's there. It's not gonna change, and that's what I consume. So then I will think like, yes, I have intermediate artifacts, but I don't expect them to change that much. But then we go back and forth with the workflow we use, and we correct some things and we add things, and the intermediate artifacts end up like actually changing. So it is, I don't know, it's something that I need to talk about. Sorry,
I
to
mean,
think about. Just-
if you go into like the make manage stuff by checking file. So make is checking the file, and this is the type. It's a bit more complicated, but it's usually like the timestamp or a hash of a file that it check. So the file can be described as hash, and then it check the evolution of a snake make. Yes, thanks, Josh.
Yeah.
And then like it check that, and if that is changed, that means like it need to be run. Target do that a bit differently, is like it check also the function you use and the source of the file. So if you update a function that generates an intermediate artifact, target will need to be rerun. We'll know like this your pipeline or your workflow is not up to date, which make
Okay.
if you change it, let's say like you have a script, I mean, you need to declare it as a dependency. Let's say like you have a script that does a bunch of stuff. It's a dependency on your make. And if you update the script that it will know that it needs to be rerun. In targets, it's a bit different, but that's should achieve that too. I mean, in a better way. I don't know. I use both personally.
Okay.
But
Yeah, I do use snake make. Yeah, but I guess sometimes I will think like, oh, this won't change. I'll just do it once and that will be it. But then I end up running everything like 100 times, and it's like, oh, I should have like, yeah, I should have made this a workflow.
Yes, I have opinion on Target. I think it's great, but I have seen people struggling using it. So if like you can regenerate your artifact in 2 seconds or 3 seconds, who cares? Like, but if it's stopping you to my point of view is like if it's stopping you like killing your session because you want to keep your object into memory, that's basically mean like you want intermediate artifacts. And if you want intermediate artifact, you should clear your mind of that and using a framework. DBT is popular also. It's not DBT and SQL Mesh are both popular. The both framework using SQL instead.
There was also a mention of running machine learning pipelines, and the chapter said that you cannot do that directly on SQL, but I think now it's possible using the orbital package, and it's available both in R and Python.
Yeah, they have like I'm not a huge expert on that. I think like the Posit team has built a whole ecosystem on using pins for object storage and using Vetiver. I think it's their modeling stuff. But what's the I mean I should spend some time, so I'm curious if you have experience, but in my mental workflow, when you generate a model using, let's say, like GLM, you're gonna generate a model which you can it's an object file that's a structure that have a bunch of stuff inside of it, and you're gonna serve that into an RDS or an RDA, and that's what you're gonna target. And so I think Vetiver is converting that model into an API call. No, that's mine. I need to do it because I have not experimented, but yeah.
Yeah, I tried it in the lab, and I also have a comment about the way that QMD file is created, because the chapter tells us that we need to separate the layers, but here the presentation layer is the QMD file, and it also contains the code for generating the API. So I think it should be separated. It should not be there.
I think I have it separated in my repo. We have an app.py and something like that.
Okay.
Or
There was there was some code in the get data section which needs to be updated because it's calling the data from a DuckDB database, but the database is not yet created.
yes, it's created in the that's what I discussed. Like it's created is a 000 QMD, the first one. It's not in the Python, but in the R script. It creates a data and then it generates the DuckDB. It convert the penguin in DuckDB for some reason, which could be a CSV too. Like who cares? At that, I mean, is being if you go into 00 QMD, the 000 no, the 001 data,
Okay.
the 1000. Thanks for doing that, Diana. If you go down, so this Python con, I think I changed it because I didn't like eval false. See, on line 21, and if you go to R, on line 30, see, like this is not running. And if you go on 39, if dir exists data, it creates it. You have a node somewhere, and then it creates the data my.db. And it's not committed because it's in the git inner, but I should commit it. Who cares? I mean, I don't like GitHub. They can pay for it. If I update frequently the data, it's gonna have a ton of artifact here, but who cares?
Okay.
And then like it's created the DB, it specified the default, it tried the penguins, and does it close it letters? It just do some tests, and it closed the connection on line 63. It's terrible code. But yeah. Does someone have like
Nice.
that's one stuff with DuckDB. It's very hard to have multiple connection on one. I mean, it's possible, but you don't want to do that. So you basically like you need to be mindful and close your connection because you cannot have multiple clients on top of one.
Okay.
It's a single, yeah.
Okay, yeah, yes. I hope I'll be able to
Yeah, I will
try
try
this.
to. But it was great presentation. Yeah, thanks for doing it.
Thank you. Thank you so much. It was a great discussion.
Yeah. And does someone want to share something, or I can free you for your Happy Friday? Well, oh wait, who's presenting next week?
I'm gonna type stop.